Hi, welcome to my channel. My name is Irfan, and today the paper I'm selected for you guys is Additional Mathematics from IGCSE session May-June 2022. And as you can see, this is paper 2. So without any further ado, let's go ahead and start with question number 1. So in question number 1, we are asked to solve this equation which has an absolute value. So first you have to remove this -5, move it to the other side and add it up with 9, which gives you 14. Then you have to get rid of the coefficient of the absolute value by dividing both sides of the equation by 4, which results in having 7/2 on the other side. And then from here you have two choices. Either the left hand side is equal to the positive version of what you have on the right hand side, which is 7/2, or the negated version of it, or -7/2. And if you carry on with solving each of these equations, you're gonna get two distinct value, and the first one would be 13/14 and the other one would be -1/14. Question number 2. We are given a relation between x and y, and also we are given an initial value of both of the variables. X is 1 plus square root of 2 and y is 1 minus the square root of 2. We have to find the value of k, and we're given a specific format which we have to follow, which looks like we're gonna end up having a cert, and a, b, c has to be found. So first of all, I'm gonna go ahead and make k the subject of my equation by dividing both sides by x squared, and then I'm gonna plug in the initial value which is given to me over here. And then in the denominator, I'm gonna use the famous identity, which is the square of sum. So the first term is a square plus the double of the product of the first and second term plus the second term squared. So if you follow exactly this identity, you're gonna end up with 1 plus 2 square root of 2 plus 2. You tidy up, you get this cert, and then you have to rationalize it. So if you want to rationalize a fraction which has a cert in its denominator, you have to multiply top and bottom by the conjugate of the denominator. So the conjugate is basically the same terms, but the middle sign has to be changed. If it's positive, we make it negative. If it's negative, we make it positive. So you go ahead and multiply top and bottom by this 3 minus 2 square root of 2. Well, the denominator basically is nothing but the first term square minus the second term square, because you can use another famous identity, which is difference of a square. And then after you multiply each term in the numerator by this, you're gonna end up with this lengthy expression. You tidy up like terms together, you're gonna have 7 minus 5 square root of 2 divided by 1, which is itself. Question number 3. We are given 3 points. We are also told that B is the midpoint of A and C. We're supposed to find the equation of a line which passes through C and is perpendicular to AB. We're also asked to leave our answer in this specific format. So as you all know, if you want to find the equation of any line, you need to know the slope of that line, and you need to know the coordinates of a point which lies on that line. So basically this is the equation I'm going to be using, and I'm going to start with finding the m, or the slope. But remember, the slope of the line I'm looking for is perpendicular to AB. So I'm gonna go ahead and find the slope of AB by using this formula. Just plug in the y and x coordinate of A and B respectively. You're gonna get -5/4. And then I'm going to be using the formula which says the product of the slope of two perpendicular lines is always -1. Therefore, the reciprocal of this after you multiply it by -1 basically give what I'm looking for, which is the slope of the normal. And then I have to find the point that this line is passing through it, and that is point C. So as you can see, point C, the x and y coordinates of it is unknown. However, I know that B is the midpoint of these two. That means if I add the x coordinates of A and C and divide it by 2, it should give me the coordinate of B, which is 6. And that's what I did here. By doing so, and a simple cross multiplication, you can find the value of P, which is 10. You do the same thing for Y. You add Q by 6, and then you take average of that. It should be 1, which is the Y coordinate of B, and that helps me to find the value of Q. So as soon as you find P and Q, you got yourself the coordinates of point C. You can plug this into this equation along with the slope that I found from here, and I'm gonna have the equation of the line I was looking for. Now I just have to tidy up a little bit and make sure the x and y is on the left hand side as mentioned here, and only I have one constant on the other side, and that is the final answer. Moving on to the next question, question number 4. In question number 4, I'm given an inequality and I'm asked to find all the values of x which satisfy this inequality. So this inequality is in a friendly format to work with because I'm given two factors. All I have to do is to find the root of each of these linear factors by putting them separately equal to 0. And the first x that I get is 1/5. The second one is 6. Now it's all down to figuring out which part of this basically parabola, because if you expand this and get rid of the bracket, you're gonna get a parabola which starts with -5x², and you don't really need to know what comes after that, because what I'm concerned with is the coefficient of my leading term, or the coefficient of x², which is negative. And as you all know, if the coefficient of the leading term in our parabola is negative, so the parabola is opening downward. Now I want you to imagine these two roots. Those are the points basically where the parabola crosses the x-axis. So this is 1/5 and this is 6. So now you can visualize basically which portion of this curve falls below x-axis or is less than 0. So it's this portion and this portion. So basically all the x's less than 1/5 and all the x's greater than 6 are the answer to this inequality. Question number 4, part B. In part B, I'm given a quadratic equation and I'm asked to show that it has distinct real roots. So these two words are actually the key words that you have to be aware of. When we are asked that our quadratic equation has distinct real roots, we have to set our discriminant delta or b squared minus 4ac greater than 0. And I should not make it equal to 0, because if it's equal to 0, therefore I could have repeated root. So knowing that this is a, this is b, and this is my constant c, by substituting these into the formula and setting it greater than 0, you just have to expand these two brackets. You can use difference of squares. So first term is a squared minus second term square, which is 1, Over here, the negative disappears. 4 squared is 16. K squared is K squared. After that, you expand this bracket one more time, and you're gonna get negative 16K squared plus 4, which is greater than 0. And then you realize these two terms cancel out, and you're left with 4 greater than 0, which is always true. Therefore, this equation has distinct real roots at all time, except when k is not negative 1 over 2, which is already mentioned in the question. Question number 5. I'm given a diagram which is showing the graph of y equals to a tan bx plus c. I'm also given a point Q which lies on this tangent curve. And as you can see, I have two asymptotes. So this branch is limited or bounded between these two. And in part A, I have to find the period of this curve. Well, I think it's very obvious by looking at the graph. You just have to see what's the gap between two consecutive asymptotes. In this case, it's 8 pi from negative 4 pi all the way to positive 4 pi. So this is 8 pi. And that's the answer for part A. In part 2, I have to find the coefficients, basically the constants A, B, and C. So finding B is very easy because I already have the period, and from the formula you just have to divide the period of a normal tangent graph, which is pi, by B, and that gives me the period. So if you cross multiply, you get B to be 1 over 8. And if you recall a normal tangent curve, which looks like that, it's passing through origin. So if this is my principal axis, I have to shift it 3 units vertically upward to get to this point. Therefore, C has to be positive 3. And now it's down to finding A. Well, now that B and C is found, if I plug in one of the points, one of the existing points on the curve, and that's the whole point of Q, which is given to me right here, all I have to do is to plug in the x and y coordinate of Q into the equation of the curve here, and then I can find the value of A. So y coordinate of Q is 7, x coordinate is basically 2 pi, and when you plug in, you get A tan pi over 4 equals to 4 after moving 3 to the other side, and tan pi over 4, that's a famous angle, that's 45 degrees, which its tangent is 1, therefore A is 4. Question number 6. I'm given the equation of a polynomial px, and as you can see, I have two unknowns A and B, but I'm given two other pieces of information which can help me to find A and B. The first piece of information is that p of x is divisible by 2x minus 3, and the first derivative of p at point 1 is 4. So I'm going to use the first piece of information over here. If p of x is divisible by 2x minus 3, then according to factor theorem, the root of this, which is x equals to 3 over 2, should make my polynomial equal to 0. So I'm just going to go ahead and replace all the x's in my original equation of the polynomial with 3 over 2. And after tidying up, you get this, which I'm going to call it equation number 1. And it shows a relation between A and B. So I need another equation in terms of A and B, which then I can form a simultaneous equation to solve for both values. and that can be found from the second piece of information here, which tells me the first derivative of p when x is 1 should be 4. So I'm just going to go ahead and take derivative of p of x. So this is simple derivative. You just take the power multiplied by the existing coefficient in front of the variable and then deduct the power by 1. And then you're going to get 18x squared plus 2ax minus 52. And if you replace all the x's with 1, you should get 4 as stated in the question. And if you do that, you realize we have no longer the constant b, because b was a constant and derivative of a constant is 0. And then basically I'm going to find the value of a, which is 19. Therefore, I can simply make a substitution by plugging 19 back into equation 1. And I'm just going to go ahead and multiply everything by 4 to get rid of the denominators. And if you do that, then you tidy up, keep b on one side, just push all the other constant to the other side, and then lastly divide both sides by 4. You get b to be 15. In part B, now that I know the value of a and b, I have to fully factorize the polynomial p of x. So I have written p of x again with the value of a and b, which we found in part A. Also, this piece was given to me in part A. We know that 2x minus 3 is in fact a linear factor of p of x. There are a few ways actually to solve this question. You can go ahead and perform long division. You can also try in other factors of number 15 and continue plugging in and see where at which one of those value the polynomial becomes 0. However, my favorite method is to use basically what's known as inspection method. So if this is a linear factor, I need another quadratic factor to actually create my original cubic polynomial after I multiply them together. So I'm going to introduce new constants a, b, c, where those are the coefficient of my leading term, the x term, and constant respectively. So a and c can be found very easily. So the strategy I'm going to be using here is comparing the coefficients on both sides. So let's start with the x cubed terms. If you look at the x cubed term on the left hand side, its coefficient is 6. And on the right hand side, you have to ask yourself, how can I get the x cubed term? There is only one possibility when you multiply the x term by x squared here. So therefore, the coefficient of x cubed on the right hand side is 2a, and a is 3. Then we're gonna compare the constants on each side. On the left hand side, my constant is 15. On the right hand side, there is only one way to get the constant, and that's when I multiply -3 by c. Doing so, you can find c to be -5. For finding the value for b, you have to be careful. First, you have to decide whether you want to compare the coefficient of x squared on each side or the coefficient of x term. So over here, I chose basically x squared term. On the left hand side, it's 19. On the right hand side, again, you have to ask, what are the possible ways for me to obtain x squared term? One way is, of course, multiply -3 by a, which I already found here, and that's 3. Together, I get -9. I wrote it over here. And don't miss out the other term, which is by multiplying 2x by bx. and that is gonna be 2bx, or the coefficient is basically 2b. And if you tidy up, you make b the subject of the equation, b is found to be 14. So now that I have a, b, c, I'm gonna replace those values, right? And then you see that the quadratic factor can be further factorized into two linear terms. You can use box method to do that. I think it's very obvious that those linear terms are 3x minus 1 and x plus 5, and that's where we stop. Question number 7. I have to write down the set of values of x for which logarithm of 5x minus 3 to the base 10 exists. So if you recall from the definition of logarithms, the argument of any logarithm should be greater than 0. So by doing that, I'm gonna make x the subject of the equation. You bring 3 to the other side and divide both sides by 5. Therefore, we get x is greater than 3/5. For part 2, we are asked to solve this equation. So basically, if you see the logarithm has no base, to be more specific, if they use the letters LG, so by convention the base is 10. And if the base is 10, so the base raised to this guy should basically give me what's in front of logarithm, or the argument of our logarithm. So 10 to the power of 1, which is 10, should be equal to 5x minus 3. And then negative 3 goes to the other side. I get 13. Divide both sides by 5, and you end up with 13/5. In part B, we are given this long equation which involves a bunch of logarithm. All of them, hopefully they have a base of y, and we're asked to find an expression for y in terms of x. We have to simplify our answer as well. So I color coded the changes I have made here. If you have any logarithmic equation, so basically the goal is to make sure all the logarithms, they have the same base and there is no coefficient in front of them. So I'm gonna move this guy and push it inside, but it's gonna become the power of 64, as you can see here. Also, instead of 4, I need to come up with a replacement, but in terms of logarithm, which the base is y as well. According to the definition of logarithm, if I wanted the base to be y, and if I want this whole thing replace the value 4, so the question is, what should I put here? And nothing goes there except y to the power of 4. And that's what I did here. Therefore, I have everything in terms of logarithm. In next line, I'm gonna combine all the logarithms on the right hand side. So the rule I used here is that since addition going on here, so basically you can multiply all the argument here, and it comes from this formula, which I'm sure all of you seen that before. So you can combine all these by multiplying the arguments together. If you do so, this is what you end up with. But now I need to make y the subject of the equation, as it was mentioned in the question. So you can do a simple cross multiplication. You end up with the y to the power of 4 on one side, but you have to get rid of the power of 4 by raising both sides to the power of 1/4. And eventually you get x to the power of 1/4/6, or you can also use another notation, which is the 4th root of x over 6. Question number 8. We are asked to take derivative of this equation, which is in terms of y and x with respect to x. So if you look at this equation, you see that y is defined as the product of two functions, 2x and e to the power of 4x. So therefore, I'm going to use product rule here. And in product rule, if you recall, if you want to take derivative of two functions which are multiplied to each other, you have to take derivative of the first one, multiply it by second one, and add it to the derivative of the second function, which is multiplied by first. So I have also color coded here to make it easier for you guys to track. The derivative of 2x is 2, and then multiply by second function plus. Now derivative of e to the power of 4x is a little bit tricky. You just have to copy paste the whole thing, but then don't forget to multiply by the derivative of the power, and derivative of 4x is 4, therefore you put it in front, and then multiply by the first function, and then this is what you end up with. In part B, we see that we are asked to find the integration of x times e to the power of 4x with respect to x. However, you see the word hence here, so that means you do not have to start from scratch, and you have to find a connection with the previous part. In previous part, I took derivative of this expression and I ended up with this guy right here. Now, according to the definition of integration, if I integrate this part here, I should get back the original expression that I started with. So that's the first thing I'm going to write. I'm going to write integration of 2e to the power of 4x plus 8x e to the power of 4x with respect to x should be equal to 2x e to the power of 4x. And somehow from within this integration, I need to extract what I've been told to find. So I'm gonna go ahead and split this integration because I'm allowed to. This is a plus right there. At the same time, I'm gonna push the coefficients outside of integration. As you can see, 2 for the first integrand and 8 for the second one. And on the right hand side, nothing is changed. So basically in the third line, what I did, I got rid of all the 2's by dividing everything by 2, and then push this guy to the other side and isolating the integration which I'm asked to find. And then also last thing, get rid of the 4, the coefficient here, divide both sides by 4. At the same time, I need to take integration of this guy. Now, integrating this is not that challenging. Basically, you write the function itself, and then don't forget to divide by 4. And that's what I did here. So after I expand this bracket by multiplying each term by 1/4, I can go ahead and add the constant c at the end. Question number 9. I'm given a vector and I'm asked to find the unit vector in the direction of this vector. So if you want to find the unit vector for any vector, basically you need to divide that vector by the magnitude of the vector itself. And the magnitude can be found by taking the square root of the coefficients of I and j, which are vectors along the horizontal and vertical axis respectively, but you need to, of course, raise them to the power of 2. And then you get the value of 41, which you can divide each coefficient by that. And this is the final answer right here. In part B, this is quite an interesting question. We are told that we have 2 points P and Q, and then the position vectors of those are P and Q respectively. And then basically we have a point R, which is somewhere between P and Q. And this is the ratio for K PR over PQ. And I think it's very obvious that the value of K is gonna end up always between 0 and 1. It can never be 1 because R cannot be Q. It can also never be 0 because R cannot reach P. It can get very close to those points, but it can never become those points. And in part 2, we are given the position vector of R relative to O, and that's lambda P plus mu Q, and we have to show that lambda plus mu is equal to 1. So let's start with what we have. So OR is here, okay? And if you want to go from O to R, you can go to P and then work your way to R. So basically I have OP plus PR, and that's what I have written here. So from what I'm given right here, I can replace OR with lambda P plus mu Q, and then OP, which is basically P, and PR is what I could find from this equation basically given to me. You make PR the subject of the equation, also knowing that PQ, if you want to go from P to Q, you have to go back to O, which is negative P, and then go to Q, which is positive Q, and that's what I got here. And then you replace it with PR. So on the right hand side, what I'm gonna do is gather all the P's together, and I have only one Q, which I can keep it there, but at the end I have to make a comparison between the coefficients of P and Q on both sides. Doing so, it's gonna lead to lambda to be 1 minus K and mu to be K. So now I just have to add lambda and mu together to see whether I get the value 1 or not. And if you do that, you see that K and negative K cancels out and you are left with 1, and that's it. I've shown that lambda plus mu is 1. Question number 10. So in question number 10, you're given the equation of a parabola which opens downward, and as you can see, there is a tangent line also mentioned in the question which is touching the curve at point A. The only thing I know about point A is its x coordinate. So this is 1.5. If you drop a line vertically downward, it's gonna cut the x-axis at 1.5. So the goal is to find the shaded region, which is basically enclosed between x-axis, the tangent line, and the curve. I have no further information about point B and C. All I know is that B is where the tangent line cuts the x-axis, and C is where the curve cuts the x-axis. So there are a few ways actually you can solve this question, but my strategy is to find the area of this right angle triangle that you can see here. So basically A all the way here, all the way to B, and then I'm gonna subtract this shaded region, the one that I shaded in purple, and that's gonna leave me with the value of this shaded region, which I'm asked to find. However, in order to do that, I need to know the y coordinate of A, that's gonna be the height of my triangle, and I need to know the x coordinate of B, because I need to know the value of the base of my triangle. So I'm gonna start with finding A, and by that I mean finding the y coordinate of A, which, as I said earlier, is gonna be the height of my triangle. So all I have to do is to plug in 1.5 instead of all the x's in the original equation of the curve, and that's gonna help me to find the y coordinate, which is 3.75. Now I got the x and y coordinate of point A. That's gonna help me to find the value of b, because in order to find the value of b, I need to find the equation of a tangent line. And in order to do that, I need to know the slope as well as the coordinate of one point which is lying on that line, and that's the tangent point basically here. So I'm gonna start with taking derivative of the original equation of the curve. That's gonna be negative 2x plus 2, and then I'm gonna replace x with 1.5, and the slope is found. That's negative 1, and this is the standard equation of a line. All I have to do is to replace m with negative 1 and x1 and y1 with x and y coordinate of point A. And this is the equation of a tangent line. Now, you don't need to tidy up and make y the subject of the equation. You don't need to waste your time on that at all, because all I need is to know the x coordinate of point B. Now, point B lies on x-axis. That means its y coordinate should be 0. And in this equation, which is the equation of the tangent line, you just replace y with 0, and x is gonna be the x coordinate of point B. So after you make x the subject of the equation, the value of it is found to be 5.25. Now that I got the value of B, I need to find the value of C. I need to find the value of C, and that's an easy task because C lies on the parabola and its y coordinate is 0. So basically this equation on the left hand side, if I make y 0, then I can find the value of C. However, by doing so, you're gonna end up having two values, and I think it's very obvious that we have to choose the bigger one, because as you can see in the picture, C is on the right hand side of the y-axis, and the other root, which we found to be -1, is falling on the left hand side, and C is the point of interest and its coordinates are 3 and 0. Now the strategy which I said at the beginning of this question, I'm gonna find the area of my triangle, which is half of base times height. This is 5.25. So if you subtract 1.5 from 5.25, you get 3.75, and 3.75 happens to be the height of point A as well. And then you need to subtract the shaded region, which I shaded in purple. That's the region beneath the curve, and it's bounded between 1.5 and C, which is 3. So those are the upper and lower limits of my integration. And this is a simple integration. All you have to do is just add 1 to the power and divide by the new power, and then plug in the limits. This is going to be a long expression. However, you can plug in to the calculator, and this is the exact value that you can get. And that's it. Question number 11, part A. So we are given the sum of the first 20 terms of an arithmetic progression, which is 1100. Also, we're told the sum of the first 70 terms is 14,350. We are asked to find the 12th term. So if you recall the formula for sum of the first n terms in an arithmetic sequence, this is the formula. Now all I have to do is to replace n with 20 and 70 respectively. I get myself two equations. You tidy up a little bit, divide both sides by 10. Over here you divide by 35. You get equation 1 and 2. You subtract equation 1 from 2. A is eliminated, and you end up with 69d minus 19d, which is 50d, and 410 minus 110, which is 300. That leads us to the value of d, which is 6. then you substitute in equation 1 or 2. In this case, it's easier to substitute in 1, and you get a to be -2. But we're not done yet. We are asked to find the 12th term. Again, if you refer to the formula of nth term in an arithmetic sequence, this is the formula. So I'm just gonna go ahead and make the substitution. A is -2, D is 6, and I get 66 minus 2, which is 64. In part B, I'm given the first 3 terms of a geometric progression, and I have to show that x satisfies this equation. That's the first part of the question. In second part, I have to show that a sum to infinity exists for each possible value of x. Now, if these 3 terms are the first 3 terms of a geometric progression, if I divide the middle term by the first term, that's going to give me r, which is the common ratio. If I divide the third term by the middle term, that's going to give me also the common ratio. And that's where I'm going to start with. And then you're going to cross multiply. On the left hand side, you get x minus 9 squared. On the right hand side, you get half of x plus 1 times x plus 6. So you expand the right hand side and then add up the like terms. You get x squared plus 7x plus 6. On the left hand side, you raise x to the power of 2 minus double of their product, which is 18x, and second term square, which is 81. And then I'm gonna get rid of this 2 down here by multiplying everything by 2. If you do that, everything on the left hand side is doubled. On the right hand side, there will no longer be a half. And then if you bring everything to one side, combine the like terms, you get exactly what we were asked to show. And since they say hence show that a sum to infinity exists for each possible value of x, you have to continue with this equation, and basically you have to solve it, which results in 2 values for x. You can use any method that you like. You can use quadratic formula as well, but I think it's a very easy factorization case. I'm looking for 2 numbers. Their product is positive 156 and their summation is negative 43. Those numbers are -4 and -39. Having said that, x1 is 4 and x2 is 39. Now, if we want the sum to infinity to exist according to the formula, the absolute value of common ratio should be less than 1. So for each of these x's that I found up here, I'm going to find the value of common ratio and see whether they satisfy this condition here. If x is 4, again from up here, if you look at the first fraction, x minus 9 over x plus 6, that's going to be nothing but my r. So now that x is 4, 4 minus 9 divided by 4 plus 6, that's -5 over 10, which is -half, and that satisfied the condition because the absolute value of -half, which is positive half, is less than 1. And same thing for x 39. If you replace the x with 39, you get 30 in the numerator, 45 in the denominator, which simplifies to 2 over 3, which is also less than 1. Therefore, S, or the sum to infinity, exists for both value of x. Question number 12, last question, which carries 8 marks. This is an interesting question. We have a container, and that's a half cylinder container, and there is no lid. It's an open container. The length of it is y, the radius is x. The only thing we're given is the volume of the container, which is 25,000, and we're supposed to find the outer surface area, S, as mentioned in the question, And given that x and y can vary, we are asked to find the minimum value of the outer surface area. So this is obviously an optimization problem since we have to find the minimum value. So I'm going to start with the volume of the container. This is a half cylinder, just like any other prism. The volume of it is obtained by multiplying the surface area of the base times the length. So the area of this base would be half of pi x squared, because what we have is basically a semicircle, and you multiply that by y, which is the length of, or the depth of the cylinder, this half cylinder, and that should be equal to 25,000 as mentioned in the question itself. You make the y the subject of the equation and you get 50,000 over pi x squared. On the other hand, we have to take care of the outer surface area. However, be careful, the outer surface area consists of two flat surfaces, one here in front, the other one at the back, and they are identical, and together they complete a full circle. Therefore, I wrote here pi x squared. And then we have a curved surface, which basically, if you unfold it, you get a full rectangle, and the width of it is still y. It's the same as the depth of this half cylinder, but you have to find out what's the length of it, and the length of it is nothing but the circumference of this semicircle when it's unfolded, and that would be half of 2 pi x, which is pi x. And that's what I got here. So the area of the rectangle would be pi x times width, which is y. And now I have to unite everything, make everything in the world of x. Therefore, I can take derivative of my outer surface area with respect to x. That's why I'm gonna substitute the value of the y with this 50,000 over pi x squared, which I found here. You do that, the x from top and bottom is cancelled. You're gonna left with 1x in the denominator. Before you take your derivative, you can actually bring the x up, make the power negative. That makes it easier for you to deal with. And you can apply power law, which says bring the power in front and subtract 1 from the existing one. And also here the same thing, -1 comes down, become -50,000, but don't forget to subtract 1 from it, which gives you -2, but I prefer to bring it down again. Now you have to put it equal to 0, because we want to find at which value of x our surface area is minimal. Well, what I did here is I multiplied both sides by x squared. Therefore, I get rid of this x squared here. X squared times 0 also gives me 0. However, here I'm gonna have a x cubed term, and you need to isolate it, bring everything to one side, divide both sides by 2 pi. How am I gonna get rid of this power? You can take cube root from both sides to take care of that. And the value of x is found, and this is basically the value of x for which I'm gonna get the minimum value for outer surface area. You do not need to take second derivative to prove that this value of x is gonna give you the minimum value, because it is already mentioned in the question itself. So you're just gonna go ahead and make the substitution. All the x's are replaced with cube root of 25,000 over pi. You key in your calculator, you get this number. You can round it up to 3 significant figures, just like what I did here, and you get 3,760. And that would be the end of this paper. I hope you enjoyed the video. Thank you for watching, and I'm gonna see you guys in the future videos. Take care.